evening, one and all. The subject name is compiler design. Previously, we discussed about some of the problems related to lexical analysis and the problems which are here now. We are going to discuss about syntax directed translation and intermediate code generation. Syntax directed translation and intermediate code generation. Now, what are that are some of the small important models that are related to here which we consider here. Now, for example, what is the syntax tree for construction of syntax tree for this expression a plus b star c minus d. A plus b star c minus d. Now, this expression we are going to identify first the that is a plus operation which is available. So that is to be considered as internal node. So we have considered internal node. To the right of this one, what is this? So that's why here plus a. So this is in the diagram plus, and here b star c. So b star c to be considered as star is an operator. So star is to be placed here, and then to the left of this b and the right of this c, and then minus it is an internal operator. To this right it is d. So like this we are going to draw a notation of a syntax tree notation where the internal nodes that is to be represented as an operator, and remaining the nodes, internal nodes and remaining nodes are represented as leaves, that is as operands. So this is the nomenclature which is following for describing this syntax tree notation. Another structure which is described, suppose a equal to b star minus c plus d. So here minus is called as unary minus. This minus is called as unary minus. So in this expression, whatever the statement that is given, so here equal to, it is to the left of this one which is a variable that is called as operand, that is a. And for this expression, what is right of this one? So this is called as b star minus c plus d. Now this is to be expanded by expanding what is b star unary minus c. So that is why unary minus c it is expanded as equal to a. So this unary minus c, this star is to be expanded with the left of this as b, and to the right of this one where you are having unary minus c. So that is unary minus with c. Unary minus with this. So this right we are having the star to this one plus operation. So the plus operation which has a right child operand is d, left child is star. So like this we are going to generate a parse tree structure for this expression a equal to b star minus c plus d. So in a simple way we are going to write this one as equal to expression variable operand here at this one, and to the right of this one we are having b star minus c. So this comes under b minus b star minus c. So this whole together is to be considered as b star minus c, and the plus d is to be followed by this one. So b plus d followed by this one. So like this we are going this side we are going to get, or otherwise we can also see the leaf nodes each terminal wide. So this one is a, this side equal to this side b unary minus star plus and d. So like this we are going to represent as a syntax tree notation. Now a 3 address structure with an expression. How the three address node can be represented with the help of an expression. So here A equal to B plus C plus D is the given expression. In this expression, what is the three address code? Here a three address code represents mainly three operands and at least one operator. At least one operator. This is maximum three operands. It contains maximum three operands. At least one operator is required. So this is the requirement to fulfill this three address code notation. So here the given expression is how many A equal to B plus C plus D. So this is one operator, this is one operator, this is one operator, and A is one operand, B is another operand, C is one operand, D is operand. So these are the operands. How many operands are required? How many are there? Total 4. So 4 is not considered. Only 3 operands are to be, well, maximum is 3. And what are the operators here? Assignment plus maximum one operator only allowed. But here 2 operators. So here it is also not considered. So in order to make this a 3 address notation, first verify we are going to substitute that B plus C. So here A equal to B plus C plus D. So we are going to make a small unit of this one, that is B plus C, and make some temporary variable T1 equal to B plus C. Now this address, this is one set of statement. In this statement, which contains the operands are T1 comma B comma C and operator plus any at least one max at least one only one operator. And here previously it is plus one operator, again plus one more operator. So here plus is only one operator. So only one operator is allowed to perform. But here we are going to perform B plus C, one operation. Again B plus D we are going to perform. So plus operand twice we are performing. But here only one time B plus C only. So that is the 3 address notation, where T1 is a temporary variable, B is operand, C is operand, and plus is an operator. Plus is an operator. Now with this expression, is it completed? Not completed. So we are going to further substitute with this one. So what is B plus C here? T1. So we are going to write T1 plus D, which is equal to another temporary, say T2. Now this also contains a temporary operands are T1, T2, D, and operator is only 1. So it is also a valid 3 address statement notation. And is it completed? No. A is assigned. Here A is assigned with the result. So that's why here A equal to T2. Now it is one operand, and at least one operator, even operator assignment is to be considered in this case. So that's why here also it is a 3 address statement. So these 3 steps is executing that the given arithmetic expression by implementing this 3 address code notation. So what is here? A is T2. Now what is T2? T2 equal to T1 plus D. Now what is T1? B plus C. So B plus C plus D. So A equal to B plus C plus. So that is the given expression. A equal to B plus C. So but instead of writing this expression, the intermediate code generation, the address code will be generated with the help of these 3 statements. So T1 equal to B plus C one statement with a 3 address code, T2 equal to T1 plus D is a 3 address, and A equal to T2. So these are the 3 address statement T1, T2, A. T1, T2, A. So these are the 3 address statement that is generated by this. So not only this, another expression which contains this 3 address. So for example here x plus y, another problem which is required for 3 address code is x plus y minus a star b plus c. So this is the assignment statement. But here in this statement, which contains the operands Operands are X, Y, A, B, C. So how many? Total 5 operands. So it is not required. So actual maximum operands are required 3 and at least one operator. So but here operators are also, what are the operators in this case? Plus is one operator, minus star, plus 2 times, minus star. So these are the operators which and maximum more than 3, greater than 3. So that's why it is also not it is not a 3 address state. Not a 3 address code. So in order to perform a 3 address code, we are going to require at least 3 maximum 3 operands, and at least one operator is required. So in order to perform this task. So here, how can you do that at this task? The given problem statement with the help of temporary names, that is T1, say T1, T2, T3, like that with the help of you can use. So for example here, A star B, if you perform, that is T1 equal to, say T1 equal to A star B. So it is a 3 address code notation. Next, X plus Y minus. So here we can perform Y minus T1 with a temporary, say T2. Now T3, T2 plus, so X plus T1, X plus Y minus T1 is T2. So X plus T2, which is considered another T3. So what T3 plus C, which contains another temporary, so T2. So these are the 3. This is 1 3 address code, second, third, fourth. So you can split this one into 4 3 address code statements. 4 3 address code statements. So that it is substituted in the form of this. So what T1 equal to A star B contains? So here T1 equal to A star B contains A is one operand, B is one operand, T1 is one operand, and operator is only star. So we can perform. We can perform this one. Similarly, T2 equal to Y minus T1. So T2 is one operand, T1 is one operand, and Y is one operand, and operator is minus. So it is easily performed with the 3 address code. Similarly, T3 equal to X plus T2. So where T3 is one operand, X is one operand, T2 is one operand, and the operator is plus. So it is also a 3 address code. And finally, T4 equal to T3 plus C. So T4, T3, C are operands, and plus is an operator. So that's why it is also a 3 address code. So like this, we are going to determine each 3 address code. And while performing this 3 address code notation, all the steps which is gives the same result previous to that given expression. So what is the given expression? X plus Y minus A star B plus C. Now in order to get this one, so what is T4? T4 equal to T3 plus C. So T3 is nothing but X plus T2 plus C. What is T2? T2 equal to Y minus T1 plus C. So X plus Y minus T1. X plus Y minus T1. X plus Y minus T1. What is T1? A star B plus C. So that is the given expression. X plus Y minus A star B plus C. So this is the T4. So T4 is also assigned to, T4 is the result. What is the result which is given is actually stored in T4. So finally T4 gives them result. So that is the X plus Y minus A star B. Like that, any statement which contains more than 3 operands and more than one operator, try to represent in the form of a 3 address code notation, and as per requirement you can use as many number of as the operators that is required temporary names T1, T2, T3, and you can generate. Now abstract syntax trees are nothing but it is a smallest representation of parse trees. So previously we generated a syntax tree notation, parse tree notations are also, but for that representation, parse trees are a small abstract representation. So here the leaf nodes are to be considered as operands and operators. Operators are internal nodes, non-leaf nodes. non-leaf nodes, internal nodes, and operands are leaf nodes. And parentheses, comma, semicolons can be omitted in abstract syntax tree. For example, let us say we are going to construct an abstract tree for 3, 2 star, 3 star, 4. And for the expression that is for the given grammar, so if the given grammar is like this, E derives T, E plus T. E derives T, E derives E plus T, T derives F, T derives T star F, F derives E, F derives digit. Now this is the given expression. For this, the resultant parse can be drawn with the help of this grammar. So what is the substitution of this one here? First one is E derives T, we applied. So this is E derives T. And second one is for this we can apply T derives T star F. Why? Because we need to get the expression 2 star 3 star 4. So that's why T star 4 is to be applied. So we cannot apply E plus T or capital E or digit, we cannot apply. So that's why here in this case E derives T followed by T star F. T derives T star F. Now what is the opera here T? What T contains? T contains to this either F or T star F. So I may get the expression F. So T F I may write. Why? Because F contains digit. So I may go to the digit with number 2. And star remain as it is, and F. F is to be contained with this expression. So F derives no expression. So F derives E. So that's why E may contain once again. E contain T star F. So here E is F derives T. E derives T. E derives E T star F. So T star F is T. So T derives F derives T. So that's why here T star F. Now T once again it is F and F derives digit. F also digit. So 3, 4. So as per the given here the grammar which we have considered based on this we are going to get. So here main idea is whatever the thing which you have drawn, the last node which is to be considered for the leaves, that is to be depicted with the here this side. If you come the these terminals, this branch of leaves which is end with node 2. So we have written 2. And this side branch node with star. So that is to be considered. And right side once again we are having 2 parts. One is 3. This is 1 and this is star, and the right side we are having 4. So the leaf nodes at the last non-leaf nodes which has the some information. That information representation is nothing but abstract syntax. They leave and leaving out the remaining information. Leaving out, so we are not writing the remaining all them. What is the process node final result at the end of this branch of the leaf? This branch of the nodes final result, that is to be considered as one node. And similarly this branch like all the branches has to be written separately. So that's why if you consider star is one branch here, for star left hand side 2 and right hand side if you go once again that is star, and for star once again 3 and 4. So see, this is called as abstract syntax tree representation. Only the nodes having the sufficient result information that is to be written finally, and remaining information can be avoided. So here while writing this we are going to substitute the expressions with the corresponding based on the given grammar notations. And suppose for example production rules are given. So here the problem is construct the production rules and semantic action for the given attributed grammar along with the syntax tree and unrooted parse tree for the given string 4 star 5 plus 6. 4 star 5 plus 6. Now to after this is the grammar. So that's why all these steps to be written. Production 1, production 2, production 3, production 4, production 5, production 6. Like this we have to represent all the information as a list of productions and the corresponding semantic action. So here construct production rules and semantic action. What is semantic action? What semantic actions are nothing but dot associated attributed values. Dot associated attribute values are nothing but the semantic action. So here semantic action for this case can be written as, what is the semantic action? Here final result is value, expression dot value. So that is to be printed. So that is called as semantic action. Whereas suppose if we consider this expression, so E derives E1 plus T. So what is the value associated for this attribute E? So that is to be written as E dot val equal to, and what is the attribute association for E1? E1 dot val plus what is the attribute association for T? T dot val. So those are the attributes associated information to be written, and these are evaluated at the time of construct in the parse tree and syntax tree notation. So that is the annotated parse tree notation. So this before evaluating we have to write the semantic actions. Based on this we have to construct the parse tree. Similarly for this E derives T, what is the syntax? The semantic actions within curly braces also we can write E dot val equal to T dot val. So this is the corresponding semantic for this. T dot val equal to T1 dot val plus star F dot val. This is the semantic action for this. And what is the semantic action for this? T dot val equal to F dot val. F dot val equal to digit dot lex value. So like this we are going to represent a semantic action. These are all called as semantic actions. For the corresponding each production we are going to represent. So after writing this one, we are going to evaluate the given expression. So what is this one? 4 star 5 plus 6. So here the given one is 4 star 5 plus 6. Now in order to do this task, first initially we will start with an S, because S is the root node. So then we have come across the, what is S contains E. Now E, we can go for either E with E plus T or E derives T. So here T is, again we can perform, but E plus T, E1 plus T we can consider. So E derives, S derives E, E derives E, capital E plus T. So we are going to, what is the expression? 4 star 5 plus 6. Suppose we have performed 4 star 5 at T place and plus operation and 6 at this one. So like that if you assume, and here 4 star 5 if you obtain that E expression must contain another star operation. So E requires star. So that's why we are going to take it as E derives T. So E derives T we are going to take this for this one. And once again we need to get this expression 4 star 5. So that's why what is the T required? T is available in two places, but the requirement is T star F. So that's why we have considered T1 star F. But what T contains either T star F or TF we can write. Here already we consider T star F, but no need to get once again star operation because we consumed star operation. If there is another star which requires, then we can perform once again. But here only the 4 is required, so that's why digit TF is required. So F means digit. So here digit is to be considered 4. Similarly, star same as this. F means here I can say F is only one derivation, so digit that is considered 5. And plus, and this side right side having the branch where the T contains T star F, TF, but T star F is not required. Why? Because it does not contain any star operation to this 6. So that's why simply T derives F we can consider. And second F derives digit, and the digit is considered as 6. So that is what we can consider the expression values. This is the attribute associated values. So here in this case, annotated parse tree, these are the annotated parse tree values. F dot val, digit dot val, T dot val, T dot F dot val. Here for each cases, we are going to represent some information. So that F dot, the digit dot value is represent 4. Now this 4 is passed to the F. So F equal to 4. Now once again this F is passed to, so T equal to 4. Now this digit is passed to here 5. After that value here 5. Now this 4 star 5. Here it performs T dot value. Here it performs T dot value. What it performs? The 4 star 5, and it declares as value 20. Now this passed to this E dot value. This is 20. Here digit value it passed to F. Here 6. Now 6 is available to T dot value. Here 6. Now this 20 plus 6, it is available at this one, that is 26. So 26 is passed to the root node, that is S. So now what is the S contains? S contains it is 26. So the same, that value it is passed, it is the. So in this way, the values are obtained from child nodes with the help of semantic actions specified for the data attribute associated values, and then we are going to get this information. So that is the how we are going to represent a production rules, and then semantic action, and then annotated parse tree. So these attribute association values are going to represent the information with each of the values described in the given string. So what is the given string here? 4 star 5 plus 6. So that is to be parsed and then return the result as 26, this information. So 4 star 5 plus 6. 4 5 is 20 plus 6, 26. So this information is to be cached out at the root. So all the leaf nodes which is passed with that information with the child nodes, once again child passed to the parent, once again, so the level up it gives the final result. So like this we can get the sum of the information. Another one also we can another example which gives the production. So here productions are given with some terms and expressions. Now semantic, we know that how to draw the semantic action. Dot attributed as, suppose if expression is there, expression dot t list dot t, and for the following grammar with the string same, a 9. So here string is different, 9 minus 5 plus 2. By using this productions, expression and terms. So we have listed out these expressions with the corresponding dot attribute associations. We are getting syntax directed definitions, and this syntax direction definition, and this is called as syntax directed translations. That means where the attribute association, suppose term 1 t dot 1. So we are going to print what is 1. Term t dot 0, what we are. So here the directed translation where curly braces which specifies the print statements. So what it is printing final, and then we can easily write this one. We can easily find out 9 minus 5 plus 2, where the expression is to be determined with list plus term, that is, and list minus term, list plus term and list minus term. So expression plus list, once again list plus term, like that we are going to get plus term. This list once again, this list is to be considered once again with some other expression, list expression, list minus term. So the sum of the expression we may contain this one, and this is to be evaluated with the corresponding nodes in the file, and this terms list is to be evaluated and term is to be evaluated separately, and depends on the production rules. Here we are going to consider the term rules which are available. Based on we can evaluate this 9 minus 5 digit, 9 minus 5, which gives the result to the 4, and 4 plus this term 2, and this 4 plus 2 given to the expression. So that is 6 is to be get the result of it. So based on the productions and the rules which are applied, we are going to verify the string and get the result. Like this we are going to get the information with that parse tree, annotated parse tree, and we can generate all these informations. All the contents which we discussed can be available in the book, that is Compiler's Principal Techniques. That is the 3 other alphabets of the Ullman. We'll come across with a new one more problem solving with another concept. Thank you once again.
Like, share and subscribe. Hit the bell icon for more updates.